Hi, welcome to part 3. In this part, I'll be calculating the nature of the turning point at x equal to minus 2 over 3. So when x is equal to minus 2 over 3, we have dy, the turning point, dy dx is 0, and our second derivative, d2y over dx squared is equal to 24 minus 2 over 3 add 2. And this is clearly less than 0 because it's negative. And to find our y-coordinate, we have to substitute negative x as minus 2 over 3 into the equation of the curve. And 2 over 3 squared minus 4, 2 over 3 at 1. And this gives us 79 over 27, which is 2 and 25 over 27. So therefore we have that x at minus 2 over 3 and y at 2 and 25 over 27 is a maximum turning point. So there we have it. We've gone through analysing this curve y is equal to 4x cubed add x squared minus 4x add 1 by finding the first derivative and also the second derivative. Finding our turning points, we have x at a half and x at minus 2 over 3. In turn, we've determined at x equals a half that it was a minimum turning point, and x at minus 2 over 3 is a maximum turning point, or a maximum. There's something else I'd like to review just so that you have a good understanding as to why we calculated the first and second derivative. I mentioned it early on, but I'm going to state it here. If we have that the first derivative, dy dx, I said that it decreases as x increases. And the model of what a maximum is that it starts as a positive gradient. We have a turning point of 0, so this is positive, 0, and then it starts going negative. It goes negative. So imagine this was your axis, and what it's indicating is that as x increases, we have the derivative, the first derivative, dy dx, is actually decreasing because it goes from positive, it goes to 0 and starts to decrease. So this indicates that d squared, d2y over dx squared is less than 0 or negative, and that it's a maximum turning point. And similarly, if we have dy dx increasing as x increases, we have the opposite, which is a minimum turning point, and it looks like this. So we start with a negative, and as we go further it goes to, so from negative it goes to 0 and then positive. So as x increases, imagine if we have our coordinate axes x and y, as x increases it moves from negative through 0 to go to positive. So as x increases, dy dx increases, and this indicates a minimum turning point. Thanks for watching this video. My name is Alistair, and I'll see you in the next one. Bye for now.